Hello and welcome to our PowerPoint module for this week. We're going to talk about univariate analysis. And this is typically the first stage in data analysis. Once you've gotten your data all prepared, cleaned up, you know what variables you have, now it's time to describe them. So univariate analysis is about describing a single variable. Okay? We're going to review various ways that you could describe variables. Keep in mind throughout that the type of univariate analysis that you do depends on the type of variable that you have. Okay, so we'll see that throughout the module today. Our objectives for this week are to first introduce univariate analysis. Many of the terms and the types of analysis we're going to talk about this week are probably familiar to you from taking math classes in grade school. Okay, so we're going to talk about frequency tables, ways of diagramming univariate statistics, measures of central tendency, and measures of dispersion. We're going to interpret some univariate output from SPSS, and I should have added this. In addition, you're going to actually work on SPSS to develop these univariate analyses on your own. Okay? I expect this will take you about an hour, maybe a little bit less, and a lot of this, again, is probably going to be review. Here are your deliverables for this week. As usual, you have the PowerPoint module and these 4 questions from the module due Tuesday night, and you do have exam 2 due on Inquire this Friday. Remember that it was supposed to be last Friday, pushed it to this week, so we do have that exam 2 due on Inquire. I will post it for you to complete by Tuesday night, so you have several days to complete it, just like for exam 1. Here's your opening question. And this is in part something I mentioned in class last week, but also something that you can get from your book. Distinguish between univariate, bivariate, and multivariate analysis. Why is univariate analysis an important step in any quantitative research? For example, before doing bivariate analysis. All right, so you can pause here, answer this opening question on Inquire, and then return for the rest. Recall that univariate analysis is the analysis of one variable at a time. Okay, so we're just looking at each of them in isolation and trying to get a sense of a few key metrics. We're trying to understand the variables that we have. There are multiple types of univariate analysis. Okay, so here's just a list, a rundown of the different types of analysis that we might consider. And this is coming from your book. First, maybe we're going to do some frequency tables. So for one variable, we have a frequency table that breaks it down and tells us how many cases we have in each category of our variable. Okay? Perhaps we're going to try to diagram what we have. Visuals are always useful in trying to get a better understanding of what our data looks like. So we could use things like bar charts, pie charts, histograms in order to visualize what our variable looks like. We also might, depending on the type of variable we have, want to do some measures of central tendency. These include the mean, the median, and the mode, and these are probably familiar to you from grade school. We're going to go through those in our module. And then finally, perhaps we're going to use some measures or calculate some measures of dispersion. That is, how much does our variable actually vary? Right? Do we have a few values where most of our cases in our sample are concentrated, or are people really spread out in the particular variable that we're analyzing? Okay, so now we have a list of types of univariate analysis that we might consider for our analysis. Which ones do we choose? Do we run all the univariate analyses we can think of for each variable? No. The univariate analysis that we choose is going to depend on the type of variable that we have. Okay, so for example, if we have a dichotomous variable, we probably want to describe it using a frequency table and a pie or bar chart, right? So we have a table to get a sense of what we have for a variable, and we also have a visual. The same goes for a nominal variable. We're probably going to use these same things. Most ordinal variables, we're also going to use a frequency table and a pie or bar chart to describe it. Now, on the other hand, if we have an interval ratio variable, it doesn't make sense to have a frequency table, right? Especially if we have something like 200 possible values for our interval ratio variable. That's going to produce a very large frequency table that's not going to be all that useful to us. So instead, we're going to use our measures of central tendency. So remember, the mean, the median, and the mode. We might use those. We also will typically have a measure of dispersion, such as the range or the standard deviation. And to visualize our variable, right, in a way that is easy for us to visualize, we're going to use a histogram. We're going to go through some examples in the next few slides to show you what this actually looks like in SPSS and to give you a sense of how these are actually calculated. Okay, but the takeaway for this slide is you need to consider what type of variable you have, right? Using those 4 different categories of variables that we went over last week in order to identify the univariate analysis that you should do. Here's an example of a frequency table in SPSS. So this is the actual output you would see if you ran a frequency table in SPSS. This is using one of the dependent variables that some of you are working with for your in-class assignments in the coming weeks. Should marijuana be made legal, right? This is coming from the General Social Survey. So when you run a frequency table in SPSS, this is what you see. And we have 2 different categories, 2 different possible responses or valid responses that our participants can give, either legal or not legal. Those are our 2 categories. And we call these the valid responses because these are the ones that we're going to count, right? These are the ones that we're going to count. If a response is missing, then that's not a valid response, obviously. Now, if we look across the various columns on this table, we see a few different categories. We see frequency percent, valid percent, and cumulative percent. Let's start with frequency. This is showing us the actual number of participants who fit into each of these categories. So in our GSS sample, 1,126 participants said that marijuana should be made legal. 717 said not legal. And our total for our valid responses is 1,843. Now below that, you're going to see a few more values. You'll see system missing, and that's 1,024. This just means that of our full sample, of all of the people who are in our sample for this analysis, 1,024 participants are missing a response to this particular question. And it's not, for the most part, it's not people who are skipping the question by choice. It's because the General Social Survey doesn't pose every single question to every single participant. They want to break it up a little so that they don't end up with these really long surveys, trying to make it a little easier on their participants. So a number of them didn't actually get this question to answer. So 1,024 are missing, and then the total on the bottom is of everybody missing or valid. How many do we have? Now beside that, you see percentages. Under the percent column, we have, basically all it's doing is taking the frequency in the previous column and it's turning it into a percentage. So it's taking, for the top one, 39.3%. That should be, I didn't calculate it, but it should be 1,126 divided by 2,867. That's going to give us 39.3%. And then down the line, you see 25%, 64%, is the total, and then we have 35%, 36% missing. Now, this isn't especially useful because usually we move on to look at only the valid percentages, so those who have actually answered the question, and that's where valid percent comes from. Now it's only looking at those 1,843 participants who answered this question, and it's breaking those down into percentages. So we see that 61% among those who answered this question said marijuana should be made legal, and 39% said it should not. Now the last column here is cumulative percent, which really isn't useful in this example because we only have 2 categories. But let's say we had several categories. What that's doing is just adding up the percentages from the previous rows, so from the row above. So if we had 3 different categories, the first value here for legal would be 61.1, and then let's say we had a second category, maybe legal or in some circumstances, then that next cumulative percent would be adding 61.1 plus whatever the percentage is for that under some circumstances category. Okay, it's not useful here. I would say pay the most attention to the frequencies and to the valid percentages. Those are the ones that are going to be the most useful in interpreting your frequency table findings. Now here's a bar chart depicting the frequency table in the previous slide. This is pretty self-explanatory, so I'm actually not going to spend much time on it here, but all you see is for legal, not legal across the x-axis, you see the percentages of participants who are saying that marijuana should be or should not be made legal. Okay, so it's just a way of graphically depicting something that we would have in a frequency table. It's pretty intuitive, and you're able to see the ratios, right? The differences in the percentages across these categories. Let's move on to measures of central tendency. And recall that our measures of central tendency are only used when we have an interval ratio variable that we're describing. Okay, so interval ratio meaning it's a continuous measure with multiple, if not infinite, possible values for our participants. There are 3 basic measures of central tendency that you probably recall from some time in grade school. The first is the mean. And this is, in order to calculate the mean, we're going to sum all values in our distribution, all the values in our sample for a particular variable, and then we're going to divide by the total number of values that we have, or the total number of participants with valid responses for that question. Okay, so that's the mean. The median is the middle point in the entire range of values. So if we were to line up all of our values from the lowest value to the highest value in order, what is our middle value? That would be our median. And then finally, the mode is the most frequently occurring value. So which value do participants report or have the most? These are 3 different ways of describing an interval ratio variable. And these can actually tell us a lot about our variable, both in isolation, so just looking at the mean we can learn quite a bit, or in combination. Say if we look at both the mean and the median, we can learn some important information about our variable. And that's what we're going to discuss in the next few slides. To continue our discussion about the mean, the median, and the mode, I want to show you a histogram. So this is a histogram, and I think it's a useful way of better understanding what the mean, the median, and the mode are actually calculating and how they're related to each other. So as I said, this is a histogram. This is using data that we aren't using in this course. This is coming from NHANES, or the National Health and Nutritional Examinations Survey, from the year 2016, and we have over 5,000 participants in this study. A histogram, like this one, is showing you across the x-axis, so across the bottom, all of the possible values for systolic blood pressure that we have. Well, that's the variable we're interested in here, systolic blood pressure, which is an interval ratio variable with multiple possible values. All right, and so our systolic blood pressure here ranges from 84 to 238. Pretty big range, right? So we see that across the x-axis, and then on the y, we have the frequency of cases or people who fit into these different values for systolic blood pressure. So the taller the bar here, the more people who fit into that value for systolic blood pressure. Okay, so that's our histogram. Now returning to the mean and the median particularly, actually visualizing the distribution like this is useful in understanding how these are different from one another and what to look out for when calculating the mean versus the median. Recall that the mean is calculated by adding up all of the values that we have for our sample. So here we'd add up the systolic blood pressure for our first participant, our second, or third, until we got all the way up to 5,535. And we divide it by the number of cases. So in this case, it would be divided by 5,535, and there's our mean. One important thing to consider when calculating the mean or thinking about the mean is if you have values that are way outside of what the typical value is for your sample, this is going to drive your mean either up or down, depending on where those extreme values are. So in this example, you'll see that we have some values that are above 200 for systolic blood pressure. That's quite high, and that's also quite unusual. So because we have some of these values that are so high and so far skewed from the rest of the people in our sample, those high values are going to drive our mean up, right? Because if you think about adding a very large number or several very large numbers into the numerator of calculating our mean, and then you divide by the number of cases, our mean's going to be pretty high. It's going to be higher than it would be if we didn't have those extreme values. This is why we say that the mean as a calculation is sensitive to outliers. This means that if we have extreme values that are way outside of what's more typical, we end up having a mean that is kind of dragged in one direction or the other. I mean, if this was skewed in the other way, where we had a few very, very small values, that's going to drag our mean down, okay? Now, the median, on the other hand, remember, we're just going to line up all of our possible values, line up all the actual values we have, I should say, and then we're going to find our middle value. So the median as a univariate statistic is not sensitive to outliers. It's not going to be driven that far up or down if we have those extreme values. This is a key distinction between the median and the mean, and this is why having both of those statistics can sometimes be helpful in understanding the distribution of our variable. The last one, the mode, is just the most frequently occurring value in our sample. So here it looks like it's at about maybe 115, 116. That would be our mode. We almost have a bimodal distribution here, which means that we have two modes that are a little far apart from each other, but the mode is simply just finding the value that is the most common, which we can also visualize pretty easily by using a histogram. Okay, so we're going to talk about this just a little bit more in the next slide, and then we'll move on to measures of dispersion. So this is another way of demonstrating the point that I made on the previous slide. When we have outliers, or what we might call skewed data, the mean is moving away from the median in the direction of the tail. Okay, so what do I mean by that? Here you see a positive skew, a symmetrical distribution, and a negative skew. So the symmetrical distribution, the mean, the median, and the mode are the same. And this is kind of a perfect scenario. Pretty uncommon that you have a perfectly symmetrical distribution. Now we might see, as you see on the left side of this slide, we might see a positive skew, and that means that there are some positive values that are outliers in our distribution, just like we saw for systolic blood pressure. So we see here that the mean is going to be driven up, whereas the median is going to be, set more in the center, and the mode is actually going to be driven down a little bit. On the other hand, if we have a negative skew, where we have some much smaller values that produce a tail in our distribution, we're going to see the mean being driven downward relative to the median. Okay, so this is just another way of depicting that the mean is sensitive to outliers. Finally, let's talk about measures of dispersion. And dispersion is the amount of variation that we see in a sample, or I should say a particular variable we're analyzing in our sample. So measures of dispersion are essentially telling us how much variation there is in a particular variable that we are studying. Okay? There are a couple of ways to measure dispersion, some more popular than others. So I have a couple of the more popular ones here. The first that you see here is the range. So the range is pretty simple. It's the difference between the minimum and the maximum values in a sample. If we just took our maximum value and we subtracted it by the minimum, we would get our range. Now, similar to our discussion about the mean, the range is sensitive to outliers, right? Because if we have one or two very high values or very low values, and those are going to be included in our calculation of the range, then it just takes that one outlier in order to drive the range way up. Okay, so the range is something that we sometimes use to describe our data, But the more common thing that you see, and again, this is for interval ratio variables, the more common measure of dispersion that we see is called the standard deviation. And this is more commonly used than something like the range because it is not as affected by those extreme values or outliers. I'm never going to ask you to calculate the standard deviation, but there is a way to calculate this. Typically, we have statistical software do it for us, right? The last thing I wanted to mention on this slide is if you're still not quite sure what we mean by measures of dispersion, look at the figure on the right side. And this is showing you 3 different distributions. So let's say we have 3 different variables here. One of them follows that normal distribution, right? It's that perfect bell curve. So we would say that this one doesn't, it has just the right amount of variation. It's rare that you see this again, but it's something that we typically compare our actual distributions to get a sense of where we are. Now you see this much more pointy curve that's labeled positive kurtosis. So in this variable, we see that people are hanging pretty tightly around a few variables right in the middle, or not variables, values, right in the middle. So there's not as much variation because a lot of people are hanging in this really narrow range of possible values for this made-up variable, okay? Now, kurtosis is a term I'm not going to test you on, but this is what we call it when we have a dispersion pattern that is different from the normal distribution. So we can have positive kurtosis, which means we have a lot of people that are concentrated in a narrow range of values. And we can have negative kurtosis, where we have a lot of dispersion. We have a lot of variation, a lot of difference from person to person in the particular variable that we're looking at. So this produces a much flatter curve with a lot more variation. But what I want you to take away from this is dispersion is about the amount of variation in a sample, and this is important for us to know. If we have a variable that doesn't have a lot of variation, then it's really hard to find statistical relationships, as we'll talk about next week. Again, I'm never going to ask you to calculate the standard deviation, but for inquiring minds, here is the equation to calculate the standard deviation for a variable, okay? Not going to ask you to calculate it, but you absolutely could. I wouldn't recommend doing it if you had, say, more than 20 cases in your sample, because it does take a long time once you get to bigger sample sizes. But if you are curious about how this is calculated, you can do this. You can do this on your own. I won't go through these steps. If you want to try it out on your own with a sample set of data, go for it, okay? But this is how you would calculate it. Finally, I want to show you what output from SPSS looks like when you tell it to calculate measures of central location and measures of dispersion. So on the left side, you see a table, and this is providing us with the mean, the median, the mode, and standard deviation for age. So I chose age. I think that's the only interval ratio variable in our GSS data. I forgot to tell it to calculate the range, but you would do the same thing and you could just get this tacked on to the table. So for our mean for age, we have 49.16, and for our median, we have 49. They're actually pretty close to each other because if you look at our histogram on the right side, we don't really have outliers. We have a somewhat funky distribution here, but we don't have outliers. If anything, I'd call this more of a bimodal distribution where we have one peak happening at around 30 to 40, and then we have another peak happening at around 60. But we don't have outliers, which is why our mean and median are pretty close to each other. Our mode, interestingly, is 57, so it's much higher than the mean and the median because that's where we have the most cases at age 57. I also told it to calculate the standard deviation, which it did. Again, didn't have to do this by hand. It's actually very easy to get this kind of statistical information from SPSS, almost too easy, just easy enough to make you dangerous because you can calculate a lot of things without fully understanding what SPSS is doing. When we do get to class, we are going to calculate these univariate statistics. I actually don't know if we'll do central location and dispersion because I don't think any of you have interval ratio variables, but we will definitely be doing frequency tables, pie charts, bar charts, that kind of thing. Okay? All right, so we just went through a lot of slides with no pause for video questions or content questions. So I'm going to rapid fire some questions at you now. And this is nearing the end of the PowerPoint module, but you do have 3 questions to answer. First, here are 2 video questions for you. I want you to watch the Research by Design video. That's on Inquire. It says link below here, but I will put the link on Inquire so you don't have to retype this link and find it that way. So I'm going to put the link on Inquire, then you're going to watch the video, answer these questions. First question, when reading frequency table output in SPSS, what is the difference between frequency percent and valid percent columns? Which column should you use when reporting your results? Second video question, how does a histogram differ from a bar chart? Why is a histogram better to use for an interval ratio variable, while a bar chart is better to use for a nominal, dichotomous, or ordinal variable? These are things that we have discussed already a bit in the module, but you will hear the instructor in the video talk about these particular points as well. Okay, so watch the video, then answer these questions on Inquire, and then come back here for your closing question. Finally, here is your closing question for this week's module. This is pretty broad. I just want to get a sense of where you are with thinking about univariate analysis. So what is one thing that you learned from this module? What is one term or concept that remains unclear to you after completing this module, if any? Okay, so you can pause here, answer that closing question, and then come back for the final slide. Here's a glimpse of what's coming up in the next couple of weeks. First, as I mentioned at the beginning of the module, you have exam 2 due this Friday. It will be posted on Inquire by Tuesday night. Your readings for next week are first, reviewing Breiman chapters 15 and 16. I know you've already done this a couple times. Focus in particular on the sections about bivariate analysis, because that's what we're covering next week. And then your second reading is a Reuters article called Eat Chocolate, Win Nobel Prize. And then finally, for next Friday, not this Friday, next Friday, your research design is due on Inquire. We talked about it in class this past week. I'll mention it again in class and ask you if you have any questions about it. Do start working on this now because it's a time-consuming assignment. There are many parts, many things to think through, and I want you to have a chance to get feedback from me before you turn it in if that's something that you need. Okay? That's all I have for you. I will see you in class this Wednesday and Friday.